quite a few. Good morning. All right, so we're going to do our ISN for the coordinate plane for sections 11.1 and 11.2. Today we'll be doing the packet, and then tomorrow I will give you the opportunity to answer questions on that and on 11.2. And then we'll be doing a review and having a quiz on Wednesday. Find the area of the triangle at the left, or we'll have a quiz in 2 days, depending on when it is. If you're in the coordinate plane, you can actually count what the base is here. So how far is it from here to here? 1, 2, 3, 4, 5. Actually, it's just 6, isn't it? So that would be your base is 6. This one is not perfectly at that point. We're going to assume it is because sometimes these are really hard to draw and put together for an ISM. Apparently, we kind of missed that point a little bit. We just want to count straight down from there, though. That would be your height. And that's 1, 2, 3, 4, 5, 6 as well. I know, but you should come to class prepared, huh? There we go. Oh. The formula for area of a triangle is base times height divided by 2. So we're going to go ahead and plug in our base and our height, 6 times 6, and divide by 2. And so that would be 18 square units. Does anybody still need this? Thank you. Okay, the next one looks like a trapezoid to me. The area formula for a trapezoid is add your bases, base 1 plus base 2. After you divide by 2, you're then going to multiply by the height. So I'm going to write down what we've got. We've got a base 1. I would just use the bottom here maybe and say that's 1, 2, 3. And then so that base 1 was 3. Base 2 will go to the top. 1, 2, 3, 4, 5, 6. And then what is the height? Well, you can count anywhere you want, perpendicular between the bases. So if you want to count the y-axis, or you could even put one right there. And it's 1, 2, 3, 4. So now we're going to pop all these numbers into our formula to find the area. Area is 3 plus 6. Then divide that by 2. And then multiply by 4. So you want to add the 3 and the 6 first. Then divide by 2. And then multiply by 4. That's going to give us an area of 4.5 times 4, which is 18. And we'll just use a u squared for the units. Okay. Next, we have a little more complicated problem in that we're going to classify the polygon first, and we're going to find its perimeter and area. So you would first plot the points and draw the polygon. It appears to be a rectangle. To verify this, use slopes to show the sides are perpendicular. The slope of AB, you would count up 1, 2, 3, and right 6. Up 3, right 6 is 3 over 6 for its slope, which would be 1/2. I'm going to go find the slope of DC. I want to start with D because I want to start with the leftmost point and climb to point C, which you would go up 3, right 6. So it's again 3 over 6 for that, which is a slope of 1/2. I'd like to see if there are right angles in the corner, so I'm going to check the slopes of BC and DA and see how they compare to the slopes we just got. From B to C, the slope is down 1, 2, 3, 4, and right 2. Down 4 is negative, right 2 is positive. That reduces to negative 2. If I count the slope from A to D, I want to go for my leftmost point. So I'm going to go from A, not from D first, and go down 1, 2, 3, 4, right 2. So I've got another slope of negative 4 over 2, which is negative 2. Now, if you look at 1/2 and negative 2, the way they're related is the slopes of the consecutive sides are opposite. They have opposite signs, and they are reciprocals. So from previous learning, we know that the sides are perpendicular because the slopes are negative reciprocals or opposite reciprocals. The next step, since now we know that we definitely have a rectangle. All right. Does anybody need this still? Okay. All right, so we already have the slope of AB was 1/2, CD 1/2, and BC was negative 2, and DA was negative 2. And the slopes were opposite reciprocals. I just filled that back in again. Step 3 says, let CD be the base and BC be the height of the rectangle. All right, so let's see. CD, right here, I'm going to find the length of that. And when we counted the slope, we went up 3, right, I did it in red, I think. Up 3, right 6, right? We could use that to find this distance. So if I call that X, the distance, or B, I guess I'll call it a B because that's what it says right here, base, we'll call it the base. If I want to find the distance of that, the easiest way to do it instead of subtracting the coordinates is to use the Pythagorean theorem. It was up 1, 2, 3, right 6. So if we take 6 squared plus 3 squared, we can get the distance. Of course, we'll have to take the square root. My pen's frozen here a second. 3 squared, there we go. 6 squared plus 3 squared, that's 36 plus 9 gives us the square root of 45. And that's about, we typed that on the calculator, please, 6 point, somebody check that, or I'll do it. Square root of 45. Everybody should be practicing this to know how to do that distance formula still. 6.7. Okay, and now we want to find BC because we need to know the height. So I'll put an H on it. We had already counted to go from B to C, which was down 3, excuse me, down 4, right 2. So I'm going to use those numbers. Square root of 2 squared and 4 squared. The horizontal change was 2 and the vertical was 4. You don't have to worry about it being negative because we're going to square it. So that's 4 plus 16. So we've got the square root of 20, which is about 4.5, I believe. 4.47, actually. Oh, yeah, I remembered it correctly. 4.5, though, we'll go ahead and round to. And now we can find the perimeter. There are 2 bases of 6.7 and 2 that are 2 sides that are 4.5. Bless you. So since we have 2 of each, I would just type the perimeter is 2 bases plus 2 heights. So 2 times 6.7 plus 2 times 4.5. Bless you. Don't hold it. Should not hold your sneezes. Well, no, you don't, but oh dear. or explosive. All right, let's let he can take care of himself. Let's just relax. 22.4 units. Now area is base times height, so we're just going to do 6.7 times 4.5. Okay, 30.15 for our area. Okay, that's the ISN. Now we're going to go to the packet. Yep. I think I better open a fresh one. Not free. You would be dead then, so don't wish that. Okay, the comment was that you wish you would be a dinosaur, that you were a dinosaur. That was, all right. There are some dinosaurs still around. All right, guys, let's go. We're gonna get a trapezoid. First step would be to look up the formula. If you don't know the formula by heart, you should be able to know where it is on your formula sheet. We're going to write it down. Area is base 1 plus base 2 divided by 2. This is how we've decided to do it, times the height. So for this, we're going to need to find the bases. So let's just count off the top and the bottom. Those will be your bases. 1, 2, 3, 4, 5, 6. You can count like that. Okay, at the bottom. Oh, I can just count because I go from 0 here all the way to 10. I know that's 10. Okay, we're going to find the height now. And you can go anywhere perpendicular between these two bases. Yes, it is 4. Thank you. Okay, so now that we have the parts that we need, and it just says to find the area, we're going to add 6 and 10 and divide by 2. Then we're going to multiply by 4, the height. I'm going to show all the steps. 6 plus 10 is 16. 16 divided by 2 is 8. So we got 8 times 4, 32. That would be an easy one that you could probably do without your calculator. 32 square units. We're going to use a U squared. Excuse me. The second figure is a triangle. The base is down here at the bottom. And the height we would count from the topmost point vertically straight down to the base. The area formula for the triangle is base times height divided by 2. Hopefully you're starting to memorize some of these. The base is how long? 2 to 10, 8. And the height, 1, 2, 3, 4, 5, 6. So 8 times 6 divided by 2. That's 48 divided by 2, which is 24. So the area is 24 square units. Anybody still need this page? For the parallelogram, the area formula, area is base times height, no dividing by 2. So this will be a quick one. Since we just want to find the base, count over on the bottom, 8 units, and then the height, anywhere perpendicular, straight down from between the bases, and that's just 3. Oh, We just need to calculate 8 times 3. And that, again, I heard you, Nathan, 24 square units. Can someone tell me the formula for the kite? It's a T. Good job. That's it. Yep. Diagonal 1 times diagonal 2 divided by 2. And the diagonals we can count. There's a long one and a short one in this kite. The vertical one is 4. The horizontal one is 1, 2, 3, 4, 5, 6, 7, 8. Is it 9? Yep. 16? No. We have to divide by 2, but that's 36 divided by 2, which is 18. Right? Okay, 18 square units on that one. No, you're not. Stop. Maybe you counted only 8 across and you did half of 32. All right, we got a parallelogram on the next one. These are the quick ones, so I'm not going too slow on this because these are nice and straightforward. We got a base of 6. We need to have a height. You can draw it anywhere you want as long as it's straight down between the bases. It could even be on the outside, guys. Any way I do it, that measurement is 1, 2, 3, 4, 5. And the area for the parallelogram is base times height. Okay, so that's 6 times 5, 30 square units. Okay, the formula for area of a trapezoid. I hope we're starting to remember them. B1 plus B2 divided by 2 times the height. Good. The top base is 3. The bottom base is 1 to 9, which would be 8. And the height, anywhere between those bases at a right angle, 4. Highlighters. All right, so the area is 3 plus 8. Divide that by 2 and then multiply by 4. Yeah, 11 divided by 2 is going to be 5.5. You multiply by 4 and you're going to get 22. Well, I don't know. The only thing I could think of is, did you possibly multiply the bases instead of add them? That's what you did. Okay. Okay, let me think how you got that. I don't know. Yeah, the parentheses do matter. Did you do the 8 first? Okay, hit 3 plus, do 3 plus 8, then hit enter, then type divide by 2. Again, because if you do this, 3 plus 8, and then you hit divide by 2, you can't do that. It's only dividing, what was it, times 4? See, that's not right. And I hit times, I mean, there's a lot of ways you can type this wrong. It's not times, it's plus. Do we need to go over any more about that, about getting it calculated correctly? I just say type the 3 plus the 8, then hit enter, then divide by 2, then multiply by 4. Right. Okay. Next, now we have a very much more involved problem here. It's asking us to find the perimeter and the area of the polygon. And it says that ABCD appears to be a parallelogram. To verify it, we're going to use the slopes to show the opposite sides are parallel. All right, the slope from A to B, we count up 1, 2, 3. I'm going to make my dashed lines, then I'll count it. 1, 2, 3, 4 vertically and right. 1, 2, 3. So 4/3 for slope of AB. BC has a slope of 0 because it's a horizontal line. Now I'm going to go D to C so I can count again. Up 1, 2, 3, 4, right 3, 4/3, and slope of DA is 0. Opposite sides have the same slope, have equal slopes, so ABCD is a parallelogram. Next, we're going to find ADB, the base, and that's going to be an easy one to count off. If AD is my base, it's 1, 2, 3, 4, 5. All right, so 5 for AD. And then the height, we already counted. It's right here. 1, 2, 3, 4. Oh, excuse me. There we go. All right, since that height's 4, now we're going to find DC, the length of DC. How could we do that in an easy way? I like using the Pythagorean theorem since we already can see it on the grid. This is 3 going here, right? So if it's 4 and 3, we can do the square root of the parallel. We're going to do the Pythagorean theorem essentially to find DC. So x squared equals 3 squared plus 4 squared, which gives us the square root of 3 squared plus 4 squared. 3 squared plus 4 squared is 9 plus 16, which is 25. And the square root of 25 is 5. Now, what that tells me, this thing's actually a rhombus because opposite sides, all the sides are 5. All right, to define the perimeter, we have 4 sides of 5. You could do 5 times 4, which would be a shorter way to do this. 5 times 4 is 20 square units. Yes? Yeah, he cut Friday. Okay. ABCD area, base times height. The base is 5, the height's 4. We're just going to multiply 5 times 4. 20 square units. Oh, wait, I made a boo-boo right there because I got distracted. What's wrong with my answer to the perimeter? It shouldn't be, right? It should just be plain units, not square units. No, that's important. I don't want to mislead you there. It's distance around. That would be in just plain units. Okay, how are we doing? Yes, Nathan. Draw and classify each polygon, then find the perimeter and area of the polygon. Okay, we're going to plot 3, 9. That's point A. You don't have to label the points with their names. I just decided I was going to. 8, 9 is point B. Now, I believe this is correct. 2, -3 on your paper. Right. And -3, -3. Kind of rhombus, because it looks to me like BC and AD are going to be much longer. Okay, so this is 5 at the top. And then if I connect down there, that's also 5, but I'm going to have some slanted sides. Now that I need to connect these long sides, I'm going to have to figure out their length because it's asking me to get the perimeter and the area of the figure. I'm going to go grab a highlighter for a second because I'm going to need to figure out, I need the perimeter. I got to figure out these lengths of A and D. Plus, I might want to check out what the slopes are. So if I do the slope of DA, how far did I go to get up there to the top? I went -3 to 9. Yeah, that'd be 12. And then to go over, I went 1, 2, 3, 4, 5, 6. Yes. Okay. This is also up 12, right 6. So I'm not going to mark it up. I'm trying to keep this a little less cluttered for visual purposes. Let's see what we got. First of all, the perimeter is going to be the most difficult part. So let's go ahead and get it. AD, I can figure out the length of, and it's going to be the same as BC. They're both going to be the square root of. Now, see how I got to up 12, right 6? I'm going to use those numbers for Pythagorean theorem. Okay, find that hypotenuse there. So AD squared, so I'm going to take the square root of 6 squared plus 12 squared. They're both going to be that same thing. So you're showing that you're doing the distance formula. So let's just get our calculator help us out with that. 6 squared plus 12 squared. 36 plus 144. I believe it's 180. Yep. And then we're going to take the square root of 180. I get 13.4 for the length of the sides here. So I'm going to mark that in red just so we can see it. Both of those are going to be the same length. Because clearly the DC and the AB are parallel. Their slopes are both 0. All right. So what we got the square root of 180, which was 13.4. I'm ready to find my perimeter now. So I'm going to add up my sides. I've got 2 5s, 2 times 5, plus 2 times 13.4. That's 10 plus 26.8. Should be getting 36.8 units. Okay. Now I'm going to find the area. Area is base. Our base is 5 times the height. Do we have a height in the picture? How do you know it's 12? Because it's 12. Okay, well, you could go out here too, right? It does. Works over there too. That's 12. You're allowed to extend the base out and make the height be on the outside. You couldn't really fit it in here because it wouldn't squeeze in there. But if you just need to know the distance between A and C, how tall it is, or how tall it is from here to here vertically. And you don't divide by 2 on parallelogram, so you're right, that is just plain 60 square units. So a perimeter of 36.8 units and an area of 60 square units. Right, should I pause a minute? Okay. Draw and classify the next polygon. So let's plot away here. -7, -2. -7, 6. Oh, it went straight up. So L, 1, 6. Another straight line to M. Not just straight line, all the lines are straight. It's just that it's a vertical than a horizontal. And then 7, -2. Oh, that one's, oh, at least it's horizontal to K. And then the only slanted one we've got to find the length of is going to be the MN. Oh, this is a classify it. Okay, LM and KN have the same slope. This is a trapezoid. I think I forgot to classify the last one, didn't I? What was this one? Parallelogram. Okay, this one's a trapezoid. So we're going to say area formula for the trapezoid. Base 1 plus base 2 divided by 2 times the height. I'm going to start finding my measurements. L to M. 1, 2, 3, 4, 5, 6, 7, 8. And how far is it? K to N. I don't want to do all those loops. Negative 7 to 7 would be 14. Okay, pen. There we go. All right, so I'm going to have to add the 8 plus the 14 and divide that by 2. If I can get it to right. Sorry, I should probably not use that thing. Nathan. All right. Divide by 2 and then multiply by the height. Did anybody count the height yet? It's 13 going from here to here? It's 8. Okay, that's 8. All right, so the area is, see, 22. No, this is an easy one. 22 divided by 2, what's that? All right, what's 11 times 8? There you go. 88 square units. I need to find MN so I can do the perimeter. All right, let's find it. M to N, the length will be the square root of. Now, I know I'm going to do that because I'm going to see a right triangle in a second. Okay, here's what I want you to try to think. What's this number, which we already figured out, 8. And how far is it from here to here? That's a 6. Okay, now do 6 squared plus 8 squared. Take the square root. Okay, so if I'm calling that, say, x, that would be like x squared equals, does anybody maybe want to see me do it like this? Yeah, and then so that's why I'm doing it, the square root of 6 squared plus 8 squared. All right, is that 10? Because this is 100, isn't it? All right, square root of 100, you get 10. All right, so MN is 10. Now we can do the perimeter. Just add up 8 and 8 and 14 and 10. Pardon me? Why? Instead of perimeter. Okay, so that's 50? No. 16, 40. 40. Hello. 40 units. Oh. And I already had you once today, Cassie. Bye. Okay. 40 square units for the perimeter. All right, one more example for your assignment for the perimeter was 40. Yeah, did I add that right now, didn't I? Yeah. That particular trapezoid, you could have done the area of a square plus a triangle. All right, let's do a trapezoid, another one. This time though, it says each square represents 3 meters by 3 meters. So that means our dimensions need to be multiplied by 3. We get things correct. So it says to find the area of your backyard. So the area of this figure, which is a trapezoid, we know the formula. I'm just jotting down the formula. Base 1 plus base 2 divided by 2 times the height. Let's figure out the base, but we're going to convert it. This is 3 units on our diagram. And this base is 1, 2, 3, 4, 5, 6, 7 units on our diagram. And the height is 1, 2, 3, 4, 5 units on our diagram. Now the mistake is to do the area formula and only multiply it by 3. Each of those boxes has an area of 3 times 3, which is 9. So you have to actually, if you area base with these numbers, you're going to need to multiply the answer by 9 to get the correct answer of the area of your backyard. So what I'm thinking is, let's just go ahead and triple the measurements right away. Okay, because the backyard, it says each square represents 3 square units. So this, if I multiply this times 3, it's going to be 9. This one would be 15, and this one would be 21. No. Okay, I'll explain too. All right, so say you did the area formula. I'll explain it. If you did the area formula without tripling those numbers in the beginning, you would have 3 plus 7 divided by 2, and then you would multiply by 5. That's 10 divided by 2, 5 times 5. So you'd have 25 square units. But that's not the actual area, because the yard is a 3 by 3 square meters for every one of those squares. So let's see what we get if we do it by tripling the dimensions. If you add 9 and 21 and divide by 2, then multiply by 15, let's see what we get. This is the correct answer for sure. 30 divided by 2 is 15. 15 times 15 is 225 square units. And those should be in meters, by the way, because it said square meters. Is 3 times 25 225?
No.
What's 9 times 25? Yep, that's why it said, because each of those boxes is worth 9 square units each. 3 by 3. So the easiest way to do the problem for you to remember what to do to get the correct answer would be convert your dimensions. There could be. To convert your dimensions by doubling them, tripling them, whatever it says each box is worth. Okay. All right, so this would be multiplied by 9 to get the actual 225 square units. Okay, you have some problems you need to practice. Once you get started on that,